Hello everyone and welcome back to my channel. Today I have decided to do a little bit of an educational video regarding statistics. So I feel like a lot of people when they go into school psych, the math part kind of freaks them out, and I'm here to tell you, like, don't worry, it shouldn't freak you out. And I'm not a statistician. Honestly, I considered myself to be pretty bad at math growing up, but I understand the stats for school psych, and you're not using everything that they teach you in stat, because you're usually taking a typical stat course. So you're gonna get a bunch of information and you're gonna need some of it, and some of it you're not. So I'm gonna go over the terms that I feel like I use when I'm testing the students, and I'm gonna try to relate it back to school psychology so that it makes more sense. And I also drew on this whiteboard that I'm going to be referring to. I know there's a little glare, so I'm also going to put a little picture where you can find this online. You can go back to this picture and refer to it, but I feel like it's really helpful. And honestly, I might even leave a link down below so that you can pull up this bell curve. I copied it from one that I found online that I felt like organized it in a good way. But anyway, let's get right into it. This is the bell curve, which is not even with how I drew it. It's supposed to be normally distributed. So in a perfect world, it would be distributed like this. Whenever, if whatever you're using has a large sample size, it will be more representative of the population because you have a diverse group of people, compared to, let's say you made a bell curve out of 5 people. It's gonna be skewed, not everything's gonna fall in the center, etc. If you have tested kids from a bunch of different states, different ages, different ethnicities, disabilities, across like the whole US, and let's say you captured about 78% of students in the US, and then you made a bell curve normally distributed with that information, that's going to have a much more representative sample. So this, again, normally distributed, you see how it starts like this and goes up. Right in the center here is the average. So that's the mean. That's where 50% of people will fall. So what I mean by that is, let's say that you had 100 students and they were all taking this test. Whatever score is in the middle, this mean, that's where 50% of the students fall. So 50% got that score. If you go over here and you get higher, the number's gonna get smaller for how many students got higher than whatever the mean was, whatever that 50% of students got. If you go lower, it's gonna be the opposite. That's where, you know, less than 50% of people got that score. So it works both ways. It's just one's higher, one's lower. With that being said, again, the mean, the average, is 50%. If you go within one standard deviation here, or even one standard deviation over here, that's going to capture most of the students' score. That's going to capture 68% of how most students scored. So again, I'm going to relate this back to school psychology. The easiest way for me to say this, if you are testing a student, let's say you're using the WISC, right? An average score is 100. That's about how much that's about 50% of students score a 100. If you want to go within a standard deviation up or down, for the WISC, the standard deviation is 15 points. So the higher end, one standard deviation, would be 115, because you add 15 onto 100 since 100 is the mean score, and then subtract 15 to get the standard deviation below the mean, which would be 85. So that means that for the score of 85 up to 115, 68% of students will fall within that range. That's the majority of students, okay? Now remember, for this WISC, for this IQ test, that's 1 standard deviation. If we go 2 standard deviations down, you're gonna subtract another 15 points. So 85 minus 15 is gonna be 70 on this side. 115 plus 15 is gonna be 130. So from 130 to 70, that's now going to capture a total of 95% of scores. So there's only 5% missing. Where's that 5%? That's in the 3rd standard deviation, and actually that's only going to be 99.7%. You go 4 standard deviations, it gets lower. You get the point? But I also have them broken down here. So from 1 standard deviation below and above, that encaptures 68%. If you're going just from the mean down 1 standard deviation, that's 34%. If you're going from the mean up 1 standard deviation, that's 34%. So together, they equal 68% of the students' scores. I hope that makes sense. And to help give you a definition for a standard deviation, it's just how far you are from the mean. So again, here's the mean, 1 standard deviation. How far are you from the mean? As you can see, the people who are 2 standard deviations or 3, they are even further from the mean, while most of the students are going to be within 1 standard deviation. This is why when we are testing students and, let's say you're trying to figure out like, oh, does the kid have an intellectual disability? Do they have something wrong with how they are functioning? If they are functioning well below the mean of the average student their same age, they're functioning like 2 or 3 standard deviations below the mean, that's a sign that, okay, this is how most kids are doing on their math, their reading, their writing. This is how most kids are doing with their fluid reasoning skills, with their verbal comprehension skills at this age. And there's something happening with this kid that they are not functioning as well. And then that's when you go into the test and you see what part are they not functioning. Is it overall, their overall score? Is it a specific subtest? You really want to find out, and this is really important in terms of comparing their scores. Okay, so it's all comparisons. Sometimes when you are looking at tests, for example, certain rating scales, they go by T-scores. Don't freak out, T-scores still go by this. So the thing is, for a T-score, the mean, so what would be in the middle, the 50%, is 50. So I feel like T-scores are really easy to remember because 50, so if it's out of 100, what's half of the amount of scores? 50. So a T-score mean would be 50. Standard deviation for a T-score is 10. So if you want to go 1 standard deviation up, it'd be 60. 1 standard deviation down is 40. So between 40 and 60 for a T-score, that encaptures 68% of students, that encaptures most of where the scores will lie. If you go 2 standard deviations up or down, you're adding another 10 for T-scores. So 70 will be 2 standard deviations up, and 30 will be 2 standard deviations down. Now, you may wonder what this means when you're testing a student. So let's say a student scores 100 overall on their IQ. Now, depending on your school, they might have a set of rules that they go by to say like, oh, a kid is gifted, or oh, this kid has a specific learning disability. But usually it involves this. So if a kid is within 1 standard deviation, you're usually like, okay, they're fine. They might need some extra support, They might not, but they're fine. They're functioning at a level that is usually considered acceptable because that's where most students are. If you go another standard deviation up, so now you're at 2, if you're on the high side, you might consider this kid gifted. Like, oh, they're actually scoring so much higher than most students. Okay, and for the opposite, if they're 2 standard deviations below, you're like, oh, they might need some support because they are performing well below where most students are. Okay, does that make more sense? When you first learn with statistics, you also get a z-score, and that is usually the raw score. So what it starts out as is the mean is 0, and it goes 1, 1, -1, -2, 2, and basically you're taking the raw score. So even when you're doing like an achievement test or an intelligence test, before you get your standard scores, you get your raw scores, and that's what the z-score is pertaining to. So they just go by like +1, 2, -1, 2, and it tells you the direction of the standard deviation. So if it's plus, you're going above the mean, and if it's minus or negative, you're going below the mean. Okay, so that's for z-scores. Something else that you might see while doing testing and also when you're in your statistics courses is significance level, and usually you're doing a 0.05, sometimes a 0.01 significance level. Okay, and don't freak out again. What that is what you are comparing your p-value to, and your p-value is your probability value. So there is a formula for that, and usually you will get whatever your p-value is depending what you're doing. So it usually ranges from between 0 and 1. Whatever p-value score you get, you will compare it to whatever your significance level is. And the reason why you are doing that is to find out if whatever you're studying, is that happening due to chance? Is it happening, due to something random, to chance? Or is it happening because of whatever this thing is? So let me give you an example because it'll probably make more sense. So for example, let's say that you are studying a program to see how well a student is reading. Is it improving their reading skills? Depending how you set that up, and then you get your scores, find your p-value. Now you want to compare it to whatever significance level you choose. So let's go at 0.05. You want to know if this program for reading, is it helping because this reading program is actually doing its job and it's helping the students learn to read? Or is it helping but it's not due to the program, it's due to something random? Like maybe it's due to whatever they're learning in class for reading. Maybe it's due to all their parents happen to be doing something at home that's improving their reading, but it's not due to the program. This is what this helps you determine, and it's obviously not 100% correct. As in, if it does seem like it's not due to chance, that doesn't mean it's 100% due to that. That's why you have your 0.05. If you find out that, oh, it's probably not due to chance, what that means is there is a less than 5% chance that you're seeing that due to chance. So let me kind of rephrase that again. What it means is that, let's say you find out that your p-value is less than 0.05 because you're going with a 0.05 significance level. That what you are seeing in this program, this reading program you made, is due to the program helping them and not due to other random factors. And the same thing for 0.01. If you're going by a 0.01 significance level, your p-value needs to be less than whatever your significance level is that you made. If you made it 0.01, if you made it 0.05, and then that will mean that if it's less than, your p-value is less than the significance level, that it is most likely not due to something random or a chance, but is due to what you are doing. And obviously 0.05 means that there is a 5% chance that what you're seeing is due to something random, and 0.01 means that there is a 1% chance that what you're seeing is due to something random instead of whatever it is that you put in place. Next, we're going to do a confidence interval, and I'm actually going to write something down on the board. So I usually like to use 95% confidence, but you can also use 90%. Let me tell you what it is first. So let's say that a student, and I'm just making this number up, let's say the student scored 92 on their intelligence test. Let's go with the WISC. Okay, now you want to have a 95% confidence interval. What that means is that you're going to get a score ranging from something to something else. And let's say you hypothetically get 82 to 99. Because you're gonna get two numbers when this runs through whatever you're using, like Q Global or something. And let's say you hypothetically get 82 to 99. What that is saying is that with 95% confidence, if the student was tested again, they would score between an 82 and a 99. So the kid got, and I don't know why I put a percent here, the kid scored 92 on this hypothetical WISC. If they were tested in a year, there's a 95% chance that they will score between 82 and 99. But there's a 5% chance that they won't. But more than most likely, their score is going to range in between there. So that's what confidence interval is. Last thing I'm going to go over is percentile ranks. So some people get really confused with this. So a percentile rank is how well the student's doing compared to other students. So let's say that a student gets the 50th percentile. That means that that kid's score, whatever they scored, is 50% or equal to most kids their own age. So for the case of the WISC, that would be 100, because that's the average. So that's 50% of students, right? So if the kid scored 100, they're scoring at or better than 50% of peers their own age. Let's say you have a percentile rank of 5. They get 5. That means the kid is scoring at 5% or better than other peers their own age or similar age range. Okay, so that would be on the lower end of that bell curve, right? If you're going to be on the upper end, you would score something like 98th percentile. That means that you scored at or better than 98% of students. There are only 2% of students that scored better than that person did. And to break it down even more, if you had 100 students overall and they scored the 50th percentile, that means they scored better than 50 of those people. If you had 100 people and they scored the 25th percentile, that means there are 25 people out of that 100 that they scored better than or equal to. If you have the 92nd percentile and there's 100 people scored equal to or better than 92 people, there's only 8 people that scored better than you out of that 100. So anyway guys, I know this video is really long, honestly probably boring because stats can be a little dry. It does get me excited though when I use these stats for the students and to help them, because you're kind of figuring out a puzzle. Like you're like, okay, they got this on this and that means this and it could be that, you know, like I don't know, I find it really fun, but I know some people find stats really boring and pretty dry. But I feel like when it relates to what you are doing in your career, it makes it really exciting. But anyway, if you were having trouble with stats, I hope that this helped you when I'm comparing it to School of Psychology. And there's a whole bunch more stats, but this is what I feel like I use and I found the most helpful in my career, because like I said, you're gonna learn a whole bunch of other things, but you don't need to be a pro at stats. I feel like you just need to get those things down, and they come more naturally when you're able to relate it to something that you're working with every day. So if you have any questions, just message, leave a comment down below, and I will see you next time. Thank you so much for watching, guys. Bye-bye.